Our aim in this video is to try to show that this integral between 0 and 1 of e to minus x over square root of x dx is convergent. Okay, so we want to prove the existence of this integral. Okay, this is an improper integral. The first thing that we need to notice is that we need to check our function. Okay, so this function is having a problem on 0, and we integrating on 0, 1. Therefore, we have a problem here on this 0. So, and the second thing is that this function is positive. E to minus x over square root of x is always bigger than 0, because the ratio of the positive functions over 0 something. Okay, so we have positive 1, and we want to apply the definition of this one, the limit as x. So here we're integrating on 0, we want to go 0 plus, okay, of x between x and 1 of e to minus t over square root of t dt. Okay, so this is the definition. The issue that we have here is that it's not great, or it's difficult to find a primitive of this one and evaluate this integral. Okay, at this level, it's not easy to find this one. But what we can do is we can use some comparison test for improper integrals. That means if we assume that this is our g, okay, this is g, and we find a function f, okay, and if we can show that the integral of this function here is convergent, then so does this one. Okay, so one key idea that we can use, since we are working on this interval 0, 1, we don't forget about this one here. The integral between 0 and 1 of 1 over x to the power alpha dx is convergent when alpha is bigger than 1, is less than 1, sorry. When alpha is less than 1, because we are in this interval 0, 1. Okay, otherwise it will blow up. It's going to be very big. So we can use this one here and see if we can find some function that can be an upper bound or an upper bounding function for this one, and we can use this one here to conclude. So we can say that e to minus t is less than 1 on 0, 1. Okay, so e to minus t doesn't have a problem on 0 on this interval. Okay, so therefore we can say that e to minus t over square root of t is less than 1 over square root of t. So this is our function that we are looking for. Okay, this is our f. So here, the 1 over square root of t dt between 0 and 1, even if this one has a problem on 0, okay, we can write it as 0, 1, 1 t to the power 1/2 dt. And since 1/2 is less than 1, this is convergent, and therefore this one is convergent when we integrate between 0 and 1. So this is the comparison test for improper integrals that would let us show that this integral exists, so it's convergent. Okay, we can do more. Maybe we can use Laplace transform by switching, or we can use a Leibniz rule. Later we will see we can use Leibniz rule when we can compute this one by introducing some other variable here. We will add one more here and make it work. Okay, so otherwise try it. So our aim is to show that it's convergent, and it is in fact using this comparison test.